Today's topic is insertion of a node in a single linked list. Well, last time we are discussed so insertion of a node at begin at the end. Today we are discussing insertion of a node at any position in a linked list. So I already told at the beginning. So the advantage of single link, the advantage of dynamic memory allocation is we can easily insert a node at any position. While in the case of static memory allocation, it is not possible. However, in the case of dynamic memory allocation, it is very easy to insert a node at any positions. So now we discuss how to insert a node at any position in a linked list. So I will give the particular position. Suppose I want to, if I give the one, so then I want to insert a node at first position. Suppose I want to give two, then I will insert a node at second position. If I give the three, I will insert a node at third position. If I give four, insert a node at fourth position. Like this. So for each element, I will give the position also. So we can traverse the list from first position to corresponding position. After that, we can insert the node. For example, we'll go first of all, we'll go for in diagrammatic way. After that, we can go for implementation. So insert a position. How to insert a node at a particular position? So first we'll take one linked list. Let us assume that this is the list. So this list has four elements. So the four elements are 24, 33, 48, 50, 52. All the nodes which are connected linearly. So this is the way we are using to connection. All the nodes we are connecting linearly. The address of the first node is always stored in start. So this is the address of first node. So the address of the first node is, so let us assume that this is the address of the first node. So this is the address of second node, 2000. This is the address of third node. This is the address of fourth node. So this is the address of first node, second node, third node, and fourth node. Now I want to insert a node, so a new node after the position 2. Suppose if I give the position is 2, insert a node, new node at position 2. I want to insert a new node. Suppose this is the new node. So I want to insert this node, new node. So this is the new node. So this is the new node. So the new node has the value 54. So I want to insert this new node. So this is my new node. So I want to insert this new node. This is the new node. So I want to insert this new node at position 2. Suppose, so what is the position? First position is 24, second position is 33. After 24, at position 2 means after 24, I want to insert this new node. So after insertion of the this, this is the new list. Suppose I want to insert a new node, 24, and first node address, and 24. So what is the value of first node? Suppose the new node address is 5000, for example. So then fifty-four. So 54 will have 2000. Fifty-four, 2000. Then 33, 3000. Then 48. Then 48, 4000. This is the first node. So this is the second node, the newly inserted node. This is the newly inserted node. This the already second node becomes to the third node. Third node becomes the fourth node. Fourth node becomes the fifth node. Fourth node becomes to the fifth node. So then so this is the process. Finally, we get the result. So this is the no list before insert begin. So list insert a node at second position list before to list before to insert node at second position. So here suppose this is the first node. The first node address is 1000. So this is the second node. The second node address is 5000. This is the third node. The address of third node is 2000. This is the address of 3000. This address of 4000. So this is the first node. This is the starting address. This is the first node. The first node address is always stored at start. So this is the first node. So this is my too difficult to teach linked list through this is the first node, this is the second node, this is the third node, this is the fourth node, this is the fifth node, then so this is the connection of nodes between first and second, second and third, third and fourth, fourth and fifth, so this is the connection. The first node will contains So this is the address of first node 1000. This is the address of second node, suppose 5000. This is the address of third node 2000. This is the address of next node 3000. This is the address of next node 4000. So the first node, as we know that already first node address is start. So I want to insert a new node temp. So the value contained in temp is 54. Suppose 54, the address of this 1000 is 5000. Let us assume the address of new node is stored in first node because so it is second position. Again, already second is in third position, third is fourth position, four is fifth position. Like this, we can insert a new node. So this is the process to implement a node, to insert a node in a singly linked list. Then we go for algorithm, how to insert. Insert node. Suppose I want to insert node. So I will write the function. First of all, first point, what is the first point? Allocate storage dynamically for the node. First, we have to allocate the storage dynamically for the node. So how we can allocate the storage temp equal to new node. This is the statement we are using to allocate the storage dynamically. Then enter value into the node. So enter the value into the node. How to enter the value into the node? See in temp arrow number. So we use temp. The node has two fields, number field and next field. You have to insert a new node in temp arrow number field. Then after that, enter the position, the new node. Enter the position of the new node. So you have to enter position of the new node. So see in position. Then traverse the list to the position. Traverse the list to the particular position. So you have to traverse. First you have to allocate the storage. After that, enter the number. Then we can traverse the position. Traverse the list to the particular position. Traverse to specified position. Traverse to specified position. How we can traverse to specified position? So then to perform this while, so first we have to assign current equal to start. Suppose I will take I equal to 0, 1, sorry, first position. While current not equal to null and I less than position. How many times you have to move the list? So position is 10, you have to move 10 times. If position equal 20, you have to move 20 times, like this. So while I less than position, simply how to move I plus plus. Next node, you have to move from present node to next node by using current equal to current dot next. So I plus plus and current equal to current dot next. This is the statement to move from first position to next position. So like this, we have to traverse. So first I will take one. So you have, suppose we want to move to fifth position, the loop we can use 5 times to move the from beginning to fifth position. Suppose 7, so you have to move the cursor to seventh position. If 8, you have to move the cursor to eighth position. So let's say in order for each time move from one node to another node, we use current equal to current dot next. Suppose I want to move 7 times to the seventh node, so you have to make current equal to current dot next 7 times. Suppose I want to move to the 10th position, so current equal to current dot next 10 times. So after this, if it is first position, assign to start. If it is first position, assign to start. So how we can assign to start? Start equal to 10. If it is not first position, if it is not first position, insert the node. Yes. So this is the way we are using how we can insert temp arrow next equal to current arrow next, then current arrow next equal to 10. This is the process we are using. So see how to insert a node in a single linked list. Suppose I want to insert a node at a particular position in a single linked list. How we can insert a node in a single linked list? First of all, you have to allocate the storage dynamically. How we can allocate the storage dynamically? Temp equal to new node. When we write temp equal to new node, so when you write temp equal to new node, then we are the new storage will be allocated. After that, enter the value into the node. So how we can use C in temp arrow number. When you use temp arrow number, we can allocate the value. Enter the position of the new node. Position, what is the position? Cn. So okay. So then we have to move the position, move the cursor to the particular position. How we can move the cursor, traverse or move the cursor? So how to move the cursor to the particular position? So for each to move the position from one node to another node, we use current equal to current dot next. Suppose I want 7th position, so you have to use 7 times of current equal to current dot next. That's why I use a looping statement to move the cursor particular position. So for that I use while I less than p, current equal to current dot next. When I write I less than p, current equal to current dot next, then the cursor is moved to the specified position. After moving the position, check it whether if it is a first node or not. If it is a first node, assign to start. If it is a first node, you say how to assign to start. If it is not a first node, you have to insert the node between the two nodes. How it is? Suppose this is the current node. For example, this is the current node. So this is the temp node. So take this node, temp node will contains the address of this node. What is this? This is current. This is current dot next 2000. 2000. What is the 2000 current dot next? So current dot next will contains 2000. That value is assigned to the temp dot next. Then the temp will be stored in the current node. This is the process. So how do we connect the node? How to connect the node between the two nodes? For example, I want to insert a node at after this node. So actually this is the current node. So the address of current node is 3000. So this 3000 will be changed by address of this node. The 3000 will be changed by address of this node. What is the address of this node? 5000. So this 3000 can be changed by 5000. So what is this current? Current arrow next. Current arrow, this is current node, this is called as next field. Current next field, current arrow next will contains the temp. So when we write current next equal to temp, the 3000 is changed to 5000. Then 5000, then the temp will be connected to this node. This is value is 3000. So temp arrow next will contains 3000. That's why I written temp dot next equal to current dot next equal to temp. This is the way to insert a node in a singly linked list. After insertion, so we can then we can implement this. The process we can use. So first if you are understand the concept, I will go for implementation. So once you can understand the concept, then I go for implementation. So students are requesting whether you are understand the concept or not. If once you can understand the concept, I will go for so next topic, the implementation. Okay. Students are understand only 2 persons are responded, 3 persons are responded, 28, 36, 49. So remaining students are not responded. 45 is also good. So very active. 505. Okay, everybody is understand. Okay, 10% of I will take 10% of the students' response. If 10% of the students is good, then everything is good. That's enough. Okay, so this is the process. Once you can implement, then this is the implementation, algorithm implementation. So once you can implement this part, once we can implement it, then we go for okay, everybody is understanding the concept. Then we go for implementation. How to implement insert a node at a particular position in a singly linked list. So you have to go for this process. What see. Please wait. System is not responding. Once it is responded, I will go for. This is already existing. So already last time we are created create display insert begin insert end. Now the new module is void insert node. This is the new module. So this is the new module I am written. So then you have to implement this module. So how to implement the module outside the class? First of all, you have to write return type. So what is the return type of the function? Void. Then class name SLL colon, then module name insert node. This is the way to write the function outside the class. How to declare some local variable. Suppose I want I equal to 1 and position, 2 variables I required. So first according to our algorithm, first you have to allocate the storage. How we can allocate the storage? Temp equal to new node. This is the first one. First you have to allocate. After allocation of the storage, then you have to enter the value. So how you can enter the value? So how to enter a value. So how we can enter a value? Temp arrow number. By using this, we can enter a value. After entering the value, then you have to enter the position. So cout, enter the position. Scene view position. Then this now. After that, move the cursor to the specified position. How we can move the cursor to the specified position? Current equal to start. We already know that the first node address is always stored in start. That address I will assign to the one variable called as current. While I less than p, you simply write this is enough. Current equal to current dot next. This is the statement to move from one node to another node. Then increment I is I plus plus. This the statement to move from one node to another node. And so we have to write one more statement, and current not equal to null. If current equal to null indicates the position is there is no there's an invalid position. So if you give the suppose 10th position, so there is no 10th position in a list, then it is an invalid position. So when we say that it is an invalid position, if current equal to null, if current equal to null, so then it is a invalid position. Otherwise, it is a valid position. So if current equal to null, if current equal to null, cout invalid position. If current equal to null, it is a invalid position. Otherwise, so it is a valid position. If it is a valid position, check first of all you have to, it is a first position. So if position equal to 1, so if it is a first node, so we say that it is a first node position if the given value is 1. If it is a first node, you have to assign to start equal to temp arrow next equal to null. This is the first node. If it is a first node, so you have to write it. If position equal to 1, so you have to write like this. Else, if it is not a first node, so that means if it is an intermediate node, so if it is an intermediate node, you have to connect the nodes. How you connect current arrow next, temp arrow next equal to current arrow next. Then current arrow next equal to temp. This is the process. So this is the implementation of so insert a node at a particular position. So how to insert a node at a particular position? So first of all, you have to allocate the storage. So how we can allocate the storage? Temp equal to new node. When you write temp equal to new node, the system will allocate the storage. After allocation of the storage, enter the value. So temp equal to temp arrow number. By using that temp arrow number, we are entered the value. After enter the value, we have to enter the position. So enter the position, C in position. Then move the cursor to the particular position. We already know the first position only. So you have, suppose you want to insert a node at 7th position, move the cursor to the 7th position. Suppose you want to move the 8th position, move the cursor to the 8th position. If you want to insert a node at 10th position, move the cursor to the particular position. So we already know that the first position is always stored in current, while current not equal to null and I less than position, PO is not. and I less than POS. So we have to move from one position to another position. We use current equal to current dot next I plus plus. I plus plus, when move write the I plus plus, we moving from first position to next position. So finally, after moving the position to particular, moving the cursor to the particular position, check whether it is a valid position or not. How we can check whether it is a valid position or not? By if how we can check whether, 1 minute. ఇప్పుడే ఇప్పుడే So current equal to, if current equal to null, indicates it's an invalid position. Otherwise, we have to insert the node in the list. So if it is the first node, the starting address is changed. So how we indicates if position equal to 1, so then it is the start node and temp dot next equal to, sorry, this is the temp dot next equal to null. The first node, so that happens. Otherwise, you have to connect both nodes. Existing node with, you have to connect the new node in between two nodes. How we connect the new node between in two nodes? So the new node is temp. So already existing node is current. So new node dot next equal to current dot next. Then current dot next equal to new node. That is the process we are using. In this way we can use. చూడండి అమ్మా, సరే తెలుగులో కూడా చెప్తున్నాను. ఫస్ట్గా మీరు ఏం చేయాలి అంటే, మీ అల్గోరిథం చెప్పినట్టుగా న్యూ నోడ్ స్పేస్ ఇన్సర్ట్ న్యూ నోడ్కి అలకేట్ అంత స్టోరేజ్ అలకేట్ చేయండి. అలకేట్ చేసిన తర్వాత వాల్యూ ఎంటర్ చేయండి. వాల్యూ ఎంటర్ చేసిన తర్వాత మనం ఏం చేస్తాము అంటే, సో సారీ ఇది కాదు, ఇది తర్వాత పొజిషన్ కూడా ఎంటర్ చేయమన్నాను. పొజిషన్ కూడా ఎంటర్ చేశాను. ఫస్ట్గా యాక్చువల్గా మనకి ఏంటి అంటే, ఫస్ట్ నోడ్ అడ్రస్ ఒక్కటే తెలుసు. మనం 7th నోడ్ అంటే కర్సర్ ఫస్ట్ నోడ్ నుంచి ఎక్కడికి వెళ్ళాలి, 7th నోడ్కి వెళ్ళాలి. కర్సర్ ఫస్ట్ నోడ్ నుంచి 7th నోడ్కి ఎలా వెళ్తుంది అంటే, సో యాక్చువల్గా ఒక నోడ్ నుంచి ఇంకో నోడ్కి మూవ్ అవ్వాలి అంటే కరెంట్ ఈక్వల్ టు కరెంట్ డాట్ నెక్స్ట్ రాస్తాం. 7th నోడ్కి వెళ్ళాలనుకోండి, 7 టైమ్స్ మీరు కరెంట్ ఈక్వల్ టు కరెంట్ డాట్ నెక్స్ట్ అని రాయాలి. సో దానికోసం మనం ఏం చేసామంటే ఒక లూప్ రాశాను. సో ఏ విధంగా రాశాను, I ఈక్వల్ టు 1 ఆల్రెడీ చెప్పాను కాబట్టి, వైల్ I లెస్ దాన్ పొజిషన్ దాకా ఏమవుతుంది, కరెంట్ ఈక్వల్ టు కరెంట్ డాట్ నెక్స్ట్ I ప్లస్ ప్లస్ చెప్పాను. సో ఎప్పుడైతే కరెంట్ ఈక్వల్ టు కరెంట్ డాట్ నెక్స్ట్ I ప్లస్ ప్లస్ చెప్తామో, కర్సర్ ఫస్ట్ పొజిషన్ నుంచి ఆ పర్టికులర్ పొజిషన్కి వెళ్తుంది. వెళ్ళిన తర్వాత ఇంకా మనం ఇన్సర్ట్ చేయొచ్చు. అసలు అది ఇన్వాలిడ్ పొజిషన్ అయితే నల్లని పెడుతున్నాము. అదే మనము వ్యాలిడ్ పొజిషన్ అనుకోండి, ఫస్ట్ పొజిషన్ అయితే స్టార్టింగ్ అడ్రస్ చేంజ్ అవ్వాలి కాబట్టి స్టార్ట్ ఈక్వల్ టు టెంప్ డాట్ నెక్స్ట్ ఈక్వల్ టు నల్. ఎల్స్ కాకపోతే టెంప్ యారో నెక్స్ట్ ఈక్వల్ టు కరెంట్ డాట్ నెక్స్ట్ ఈక్వల్ టు టెంప్ అని చెప్తున్నాం. దిస్ ఇస్ ద వే టు ఇన్సర్ట్. సో ఇది ఇన్సర్ట్ టు డిస్ప్లే, ఇవి ఆల్రెడీ అవసరం లేదు కాబట్టి ఈ పార్ట్ తీసేస్తున్నాను. సో ఇన్సర్ట్ క్రియేట్ చేశాను, లిస్ట్ ప్రింట్ చేశాను. ఆ తర్వాత మనకి ఏంటి అంటున్నామంటే, S1 డాట్ ఇన్సర్ట్ నోడ్, called the function S1 dot insert node. Then you have to print the list, see out the list after insertion. So this is the process. Finally, we can write the menu-driven program, menu-driven main. So finally, after insertion of all the nodes, we can write the menu-driven approach for all the modules. Actually, first of all, we are testing each and every module. After testing all the modules, then we can write the main program in a menu-driven approach. So when you write in menu-driven approach, so then we can call whatever function we require. That's the final process. So I will write at the end. So now it is the first part. Enter a new node. Suppose enter the number 21. Yes. 32. Yes. 43. Yes. 54. Suppose. Do you want another node? No. So the list is 21. What are the values we are given? 21, 32, 43, 54. This is the my list. So for new node, what is the value? Suppose I want to insert a node 67. Enter the position. At what position you have to insert the node? Suppose I want to insert a node at third position, 3. So that means after second thought is the new node. That means 67 will be in third position. Oh, we are not written display function. That is the problem. S1 dot display. 21, yes. 32, yes. 43, yes. 54, no. So the 21, 32, 43, 54. Enter the new node. Suppose 67. At what position? 3. Suppose if I give the 3, the new value 63 is inserted fourth position. I think current is the current. The new node is inserted after the position. I think. 1 minute. Why I what is what I one less than one less than one. No, I take. So we are inserting a node after a particular position. Actually, like this, we can insert at a particular position, no problem. Twenty-one, 32. Sorry. Invalid position. Suppose I have given that is the invalid position. 21. We want to insert a new node is 32. Yes. 43. Yes. 54. We want to insert a new node. No. This now. Enter the value. Suppose what is the enter the value? Suppose 67. At what position? Suppose I want to given 3. So the new node is inserted at third position. No problem. So this is the way to insert a new node at a particular position. After position means you have to give position I less than position. At particular position I less than p minus 1. Position minus 1. This is enough. So like this we can insert a node at a particular positions. After a position or particular positions we can use. So this is the way to insert a node in a single linked list. This is the process we are using to insert a node in a single linked list. This is the process. This is the way we are using to insert a node. Okay. Thank you. So tomorrow we'll discuss the next topic, how to delete. So this insertion we have the 3 modules. I told the 3 modules. So we can call the fourth module also. If I less than POS, insert after the position. If I less than PO position minus 1, insert at a particular position. That's our 2 modules we will take it as a. Actually, we call this one type. So insert begin, insert end, insert node. Similarly, we have the delete begin, delete end, delete node 6 and create one 7 and displays 8. So these are entry with reverse. I will tell you reverse also. So this is the way to insert a node in a single linked list. Okay, this is about insertion of a node in a single linked list. Okay, thank you. I think you are understand the concept. So okay, we'll go for next topic. Okay, we discuss. Okay, bye. Okay, students are, I think students are understand very well.